and it's going to cost triple, so don't do it. And he said, okay. We first observed this problem in the very sensitive DE filtered systems, DE filtered grid systems. People were getting short filter runs. And I kept getting said, water was clear, but the runs, you see what was happening, and all of them were using dry acid to lower the pH. But it was grabbing a little of this calcium and clogging the filters. So how do I know? I got a sample of the residue. I washed out the DE, separated it, and checked it, and I found a super high level of calcium sulfate. I said, you gotta stop using the dry acid. Now, to solve the problem immediately, you could flush out some of the water, dilute it, and then come back, and then switch over to muriatic. The problem quit. Since that occurrence a couple of years ago, I've noticed that poolgeniusnetwork.com, an online chat group, has also, a number of the people there have also even shown pictures out west, where salt generator systems are so prevalent, of precipitates related to calcium sulfate. So, enough said on that. This is not a hard water area of the country, so you're not likely to encounter this the way they do out west, where the calcium levels are high. But if we're in a plaster pool and we're running 250 ppm of calcium or even higher, it's certainly valid to stay away from that granular acid. Any comments or questions about this? Okay.
I have something to say about that. We had PPG, which is a Cal Hypo system,
yes,
in a big commercial pool, and they had a vacuum type DE system, and the guy was using I don't think he was trying to lower the pH, but
now you could also be using pH decreaser or muriatic to lower the total alkalinity.
I'm not sure he had a problem with the pH.
Right, okay.
But what was happening is his grids were getting clogged up almost every other day. I mean, this is a big system where you get a garden hose and you drain your tank and rinse them off. But they were constantly
well, let's look at that. Let's capitalize on that notion, because one of the areas of water balance, the only other main area, is the calcium hardness. Now, just since that's a Cal Hypo system, it's possible that the calcium hardness had elevated, like the old Langmuir index, to the point where the pH, the effective pH ceiling, kept going lower and lower. So the useful pH before stuff started to crap out, whether they were using dry acid or it didn't matter, it would have been calcium slowly coming out of solution because the pH was a little too high. So one of the initial remedies would have been a quick lowering of the pH and see if that cleared it up. Because if you have a cloudiness due to calcium, and it's a calcium carbonate or a calcium hydroxide, the primary calcium, acid will clear it up like parting the Red Sea within seconds.
Well, that's what we suggested, and the operator claimed that everything was balanced. And
it is possible that they had a calcium sulfate formation.
The other thing that they were putting in that pool in large quantities were enzymes. They were using natural chemistry enzymes, and my feeling, what was happening was there was like a plastic film clinging to the grids, and my feeling was the enzymes were probably taking oil and grease out of the inside of the pipelines and depositing it on the DE grids.
That's right, and they will pick up calcium.
And it looked like you could actually peel it off. It looked like cellophane that was on there.
When they call like hard water and soap, the enzymes will also bring the calcium into the picture, cell mixing. That's definitely different, a different issue, certainly. Now, there's one other product to kind of stay away from that has a lot of sulfate, and that's the oxy. The non-chlorine shock is potassium monopersulfate. And it has a good specific use. primarily for chlorine removal or shocking indoor pools. But that's another one of those is that you really wouldn't want a steady diet, especially if you're on a generator, a chlorine generator system where you're adding acids and sulfates.
They're throwing a lot of clarifier in there.
Clarifiers?
Yeah. Well, wouldn't that stick to the DE grids and?
It could. Now, there's been a long-standing question: is it okay to use clarifier in DE systems? And I say no. I agree. It's technically I don't find much fault, but the tendency for clarifier to grab onto other things, to enlarge itself on the molecular level, is so great. They call it cross-linking. So it gets bigger and bigger and bigger, then it gets caught up. And a good DE system just shouldn't need a clarifier.
I've seen it a lot on commercial pools where the lifeguards throw in so much clarifier because they think it works so great. But you know, you take the tanks apart, you got that much of your sand is just garbage.
That's its main use for sand filters.
Yeah.
I've seen it where I have seen it with algicide, the foam type algicide, where they've had so much in there that they've actually lubricated the sand.
Mm-hmm.
And you'll force, if there is a layer where the clarifier is coagulated, you're going to force some channeling as a result because something's got to go through, or else the back pressure will be so high, you know, you'll have to flush it out. So you're going to get plenty of warning signs. But if it does, you'll lubricate the sand, then it'll stay cloudy and it'll work against you. But clarifiers are, you probably thought about that when I said about cloudiness. Mineral cloudiness is easy to solve for the most part by quickly lowering the pH. Organic cloudiness is the trickier one where you have clarifiers and other agents, ways of treating the filter, changing the sand. At least there are a few things, but that's for the most part a filter-oriented problem. You'll never clear up a mineral cloudy pool with filter aids or clarifiers. Never. You'll get some of it to drop out, but there'll always be a good haze to it. That will generally be removed by lowering the pH quickly. Now, in many cases, like with scale, you actually have to quickly overshoot. You can't just bring the pH back down, say from 8.0 to 7.2, because there's a tremendous amount of energy trapped in crystals. And just lowering the pH to the normal level won't dissolve any crystals. And throwing in a lot of sequestrant generally is very slow and doesn't work. The only way is to really torture it and go all the way past for a brief period of time down to pH of 5, for example, to provide enough acid effect to melt away the crystals. Sounds a little bit risky, especially if there's a heater in place. You can only do this for maybe a day or two, but we have many commercial customers in New Jersey who perfected that, and essentially it's an in-place acid wash. You could see it, you've done it.
Yeah.
It's the only way. Now I've seen scale form over the course of a winter. Probably for the most part, newly plastered pools in the fall are vulnerable to this. It'll zoom up over the winter, and you'll come in and the water will be clear, but you can have some really strong scale. So strong that you almost have to go with a full strength acid wash. I've actually been there and scraped off, popped off, and put it in test tubes, this type of scale. And it laughs at 50-50 muriatic water.
Gee.
So be prepared for anything out there. Because you'd like to, for the most part, in terms of using acid to solve a mineral problem, scale being an example of a mineral problem, you'd like to start with whatever your normal safe dilution. 1 to 3, 50-50, but I've seen plenty where you're at it 100%. Now, that's an issue, it's tough to do. But I've seen also for light scales, I've seen people take and kill out the alkalinity, use enough muriatic acid to reduce their alkalinity level to 0. And you need, just for the record, about 1 gallon of muriatic in 10,000 gallons of water knocks out about 50 ppm of alkalinity. So take 1 gallon per 10,000, 50 ppm of alk. So if you've got a 200 alk and 10,000 gallons, just to do this, to wipe it down to 0, and then you'll need some more. You're talking about a case, 4 gallons per 10,000 gallons. 30,000 gallon pool, you're talking 3 cases of acid. Sounds like a lot, but we know it's real. That's just to get you back to basically a mid-6s pH, where you have a 0 alkalinity and your pH down is about 6. And for the record, alk starts to bite and show a reading when your pH is around 6.6 to 6.8. That's where it starts to bite in. Do you want to dissolve some scale? You got another case of muriatic. You're probably at about 4 cases. You like what I'm saying, don't you?
Well,
Just saying you've done it.
I'll put easily 15 gallons in a 20,000 gallon pool.
Yeah, it's 4 cases.
Kill off scale.
Case 4 by 1. Yeah.
And
Now,
just let it sit for a couple of days and just brush the hell out of it.
that is exactly the trick, and you can do that with relative safety, even with a heater present. But then
But leave
after,
it
then
off.
you gotta move it. Then
Yeah.
you gotta move. And did you pop off a lot of junk when you brushed
Oh,
it?
yeah.
That's the way. So I'm not teaching anything new, just reinforcing that other people are doing this.
Mhm.
Now, when you wanna come back, calculate all that acid you threw in. You knew the first so much went to kill out the TA, then you had the extra, okay? To reverse it, a gallon of muriatic, you need about 10 to 12 pounds of total alk to balance it off. Most people who do acid washes know how much they gotta carry a bucket of pH increaser to neutralize the acid from an acid wash. 1 gallon of muriatic is offset by 6 pounds of pH increaser, or about 12 pounds of total alk. Take your pick. Total alk's again safer, more expensive. Have that on hand if you're going to do a radical pH adjustment treatment, kind of keep a count. So if you know you've brought to 0 and you choose to put excess acid to help solve the problem, you'll need a bag with you of total alk, maybe a big bag. Okay. So now in a funny way, we've covered all the aspects of the water balance. The calcium hardness has a very broad range. Here we say 210, but there are many pools. It's like above ground pools, all plastic. There are no metals involved in the system, and they don't even know what calcium hardness is. They'll run at 30, 40 ppm, and the pool pretty much runs fine. But if you have a heater, or if you have a plaster pool, or if you have any metal fittings or metallic surfaces, it's very valuable to at least balance the pool up to around 210. Now, on the high side, we know that in western parts of the country, Arizona, Texas, we see pools to start with at 350, 400. They're a little tougher to manage. They must keep the pH down. If you're forced into a situation with high calcium, you must run the pH as low as possible and run the alkalinity as low as possible. So there are plenty of pools around the country with a 7.2, a 60 alk, and they got 400 on the calcium. Now, the only way to get rid of calcium effectively is to flush out the water and have water available that's low in calcium. There are chemicals, including Conquest, that you can throw in, but they'll milk the water endlessly because the amount of weight, the only way to get rid of the calcium is to force it into some type of a precipitate and filter it out. And that's extremely messy and just doesn't work. You'll get a layer at the bottom, you get a cloud, and you'll be wasting time forever. It's better to just try to coexist and adjust the pool for high calcium. On the low side, you could build it very easily with calcium chloride dihydrate, basic calcium hardness it's called. And this chart shows the kind of poundage necessary to take very soft water, for example, where it started with 50, and bring it up to 210. And it's big numbers. When you look at a 30,000 gallon pool, you're talking about a 60-pound supply. So it's not unusual to build up hardness with 50 to 100 pounds of calcium. Now let's talk quickly about the gunite pools, plaster pools, and especially the newer ones. I am not a fan of seeing the calcium level raised beyond 100 to 150 on the onset of a freshly plastered pool. There's a lot of literature on this. There's published information in the National Plastering Council on a startup procedure. But those walls are going to cure and bleed calcium into the water. And I've seen it raise it up 50 to 100 points on its own. So I would not be, I'm no fan of moving quickly.